Today, we are going to dissect the terrifying mechanics behind the catastrophic flash flood that struck the Nepal-China border on August 26, 2026. This wasn't your typical weather event, and understanding exactly how it unfolded is absolutely fascinating, but also entirely sobering.
Part 1. The 9-meter wall.
To truly grasp the scale of this, imagine you're just standing beside a river, going about your normal day. Then, completely out of nowhere, the water level violently surges by almost 9 meters, swallowing everything in its path. Just think about that height for a second. 9 meters. That is roughly the height of a 3-story building, appearing in the blink of an eye.
And it happens incredibly fast. At 0 minutes, you're looking at a completely normal river. Fast forward just 30 minutes, and that exact same river has risen by up to 9 meters. 30 minutes? That incredibly condensed window gave the folks living downstream practically 0 time to react. The sheer suddenness is really what defined this tragedy.
Part 2. Anatomy of a collapse.
So, what actually triggered this?
Well, as I mentioned, it wasn't a rainstorm. There was no massive downpour or weather forecast warning people to run for higher ground. Instead, the catalyst happened way up high in the Himalayas, completely out of sight. A massive chunk of a glacier and the surrounding rock just gave way. And it collapsed with such incredible, earth-shattering force that scientists actually recorded it as a magnitude 5.2 seismic event. I mean, the mountain literally shook from the immense power of all that falling ice and stone.
Here is exactly how a disaster like this builds. Step 1, you have that violent initial collapse of the glacier and rock. Step 2, as it plummets, it mixes with an absolute massive amount of mud and water. Step 3, this enormous turbulent concoction plunges directly into the Lhende Khola river below. And finally, step 4, instead of just settling there, the whole mass dramatically accelerates, picking up terrifying speed as it gets funneled down the steep mountain valleys.
Part 3. A river of concrete.
That funneling effect brings us to the physics of why this specific event was so extraordinarily destructive. We really have to look at what this river transformed into. What struck the valley was what experts call a debris flow. This is a violently fast-moving mixture of water, rock, mud, and ice that honestly acts way less like a normal river and a lot more like a moving wall of concrete.
To really grasp the destructive power here, think about the contrast. A normal flood is often a relatively clean wall of water, kind of similar to a tsunami wave. But the Nepal debris flow was literally a moving concrete wall, packed with enormous amounts of rock, ice, mud, and sediment. That insanely dense, heavy composition is exactly what gave it the brute force needed to just rip apart solid roads and make massive bridges quite literally vanish from the landscape.
And it wasn't just impossibly heavy, it was unbelievably fast. Preliminary observations indicate the debris flow reached terrifying speeds of around 50 meters per second. To put that into everyday terms, that equates to roughly 180 kilometers per hour. Just try to picture a wall of wet concrete hurtling at you at highway speeds. And because those Himalayan valleys are incredibly narrow and steep, the flow couldn't just spread out and lose its energy. It held on to that highly concentrated momentum, tearing downstream for more than 20 kilometers. For 20 continuous kilometers, it utilized those tight valley walls to keep its destructive force fully intact, flooding and sweeping away absolutely everything in its path.
Part 4. The climate connection.
Now we have to zoom out from the devastation on the valley floor and look at the bigger scientific picture. Why did this glacier collapse in the first place? Well, scientists are actively piecing together the exact chain of events. It's a massive, complex puzzle involving geography, geology, and shifting environmental conditions at extreme altitudes. Here are the crucial factors researchers are reporting right now. We know for sure the Himalayas are warming rapidly. This rapid warming leads to retreating glaciers and thawing permafrost, which fundamentally weakens the mountain slopes. That undoubtedly increases the overall likelihood of these types of catastrophic collapses. But, and this is a really important caveat, the direct link proving climate change caused this specific August 26th event is still under investigation. Scientists are carefully pointing out that it is simply too early to make a definitive, singular connection, even if the broader environmental trends clearly point to a changing and shifting landscape. To wrap up this explainer, this entire disaster serves as a profoundly terrifying reminder. Danger in the Himalayas doesn't always begin with rain.
A lethal threat can start thousands of meters above you with a sudden slope or glacier collapse, totally out of sight, transforming a calm river into a roaring torrent of death in mere minutes.
It leaves us with this final, chilling summary of nature's raw power. One glacier collapse, one enormous debris flow, and a flood wave that rose nearly 9 meters. It forces us to ask a really difficult question before we go. How can communities possibly prepare and protect themselves when profound danger doesn't just fall from the sky as a storm, but collapses without a single warning from the silent peaks above?